Okay, welcome back to Physical Science once again with Mr. Wilson. Today, I'm recording a demonstration on liquid nitrogen. So I know at the camera it's a little bit hard to see, but what is in my styrofoam container here is liquid nitrogen. We already did our dry ice investigation where I went over how dry ice goes from solid to gas, has a sublimation point, since it doesn't go to liquid, of negative 78 degrees Celsius. Liquid nitrogen has an evaporation point, so going from liquid to gas, at negative 195 degrees Celsius. So this stuff is much colder than even dry ice is. You really want to be careful with this stuff. It's really hard to get your hands on, except for educational purposes and a few industrial purposes. But it's really cool that we can do some demonstrations here, and that's what I'm going to get going. Once again, 5-minute video. So I'm going to start making my brew here. I'm just going to start throwing stuff in, and then hopefully we'll be able to get the demonstration of it too. So here goes a gummy bear, marshmallow. Here's a rubber bouncy ball. So you can see it actually, it's bouncing. A little bouncy ball goes in. Let's throw in a balloon. So there's my balloon on top of everything. Kind of use it to push everything down. So normal balloon just filled with normal air. This is going to be probably video 1. I'm going to end up doing 2 or 3 videos. So watch out for those if you like this one. So once again, I'm using my tongs. So I don't have to touch anything directly. I got gloves over there if I need them at any point. We're just kind of throwing everything in there and letting it cool down. So liquid nitrogen, when it goes to that vapor, and as it's a liquid, very cold, transferring, it's absorbing the heat from all this stuff. So in order for it to go to a gas, it has to absorb the heat. And as it absorbs that heat, that stuff is cooling down. Look at what it's doing to my poor balloon over here. It is turning my balloon small because the pressure, the volume is actually going down. As it cools down, the kinetic energy is shrinking, and it's taking my balloon in. And at the same time, the plastic, the rubber of the balloon, is getting more brittle. So both things are happening at once. And when I take my balloon out of liquid nitrogen over there, it's just going to slowly reinflate. The warm air from the room is warming it back up, and it's going to get back to its original form. So there's my balloon demonstration. As the temperature went down, the volume went down in accordance with that. So kind of fun sometimes. Here's my marshmallow. It's been cooking for a little while. And of course, over to the side here. Nope, don't want to touch that quite yet. Over the side here, I have a trusty hammer, because who doesn't like a good hammer? And, kind of looks more like Lucky Charms marshmallows at this point, even though it was a nice fluffy marshmallow, squishy marshmallow to start out. Some people like to eat those even if you ever sort of like Dragon's Breath ice cream or anything like that. It is somewhat safe to eat because of the difference in temperature. I'm not going to because it's kind of old. I'll do another demonstration with that later on. Let's see if my gummy bear way down there is ready. Gummy bears are always the messiest. Oh, a little piece of its leg broke off. There it is. So half of my gummy bear lived. Oh, that's cool enough now. Off to the side. There, you can see my little half of a gummy bear. As the stuff cools back down, it gets gummy again. So now it's like glass. The gummy bear shattered like glass with my hammer. Not really anything special there. Let's throw on my glove for this last one for this video, which is the rubber bouncy ball. Remember how bouncy that thing was just like 2 minutes ago? Well, it's had time to cook in my liquid nitrogen now, so I'm going to take it off camera. I'm going to drop it straight down from about 4 feet up. That's not bouncy anymore. So it's actually very brittle now. It's compacted and gotten more brittle and kind of break apart like that. And then as it warms up, it's going to go back to its natural state. If you were in class in a few minutes, I'd let somebody come up and touch it. It would go back to being very rubbery. There's video number 1. Watch out for video number 2 where I do some more cool stuff.